Before we start, are there any questions, any lingering concerns coming up? Okay, so today we're going to talk about uh, a few things that we're going to review abstract classes at some point. We're going to talk about this term downcasting. We've talked about upcasting, and there's up. If there's up, there's down. Whatever goes up must come down. But first, we're going to talk about. I just realized that this isn't the best way of saying this. Um, Basically, what I would rather say, because extends, the reason is extends has a particular meaning. How about enhancing? Okay, we'll see what that's about in a second. Okay, so again, rather than technically correct from an English standpoint, a little bit potentially confusing. The way I'm using it here is I'm not extending as in subclassing. The idea here is now we have in the subclasses, and we're referring back to our instrument example. This is my instrument example. Again, there's a nice example in the book that's similar, but the idea here now is that each of these subclasses, each of these subclasses now enhances its by it adds more functionality by adding methods that do not exist in the superclass. So from a design or an organizational standpoint, what you want to do is you want to take all of the functionality that's common and put it as far up the inheritance tree as possible. In other words, ideally, you have a superclass in which all of the common things that you do is in one place. Why do that? Why not just kind of duplicate it everywhere? Well, for several reasons. One is, as we've seen, by defining things like homogeneous things like an array, I can define an array, as we've seen, of, say, in this case, of an instrument, and I can put in any one of these instances and any or all of these instances into that array, and they will work because of upcasting. In other words, because because each of these is a superclass, then it can go into the array without any problem. You can't go the other way. If I have an array of violins, I can't put something that's just an instance of an instrument in, or if, for example, if I have an array of violins, I can't put a cello or a trumpet or a French horn in. Okay, and that's a good thing there too, because if I have nothing but violins and I expect them to be violin-y, then I don't want to have like a trumpet in there kind of mucking things up. But so here again, I still keep forgetting this T here. I have to. Okay, so so the idea, I don't know why I said strings here, but so here a violin adds, in this case, we've added two specific methods, pluck and bow, and similar ones to the cello. Why are they different? Because being different instruments, they actually physically involve different things. But this actually makes a case for, again, another refactoring of design, so that one could envision taking these common elements and then putting them into a strings class here, and likewise with the brass ones, putting the brass in. Again, this is kind of what the book does. So that's kind of a reason to follow that. Now, what we did yesterday, if you remember, is that we decided then, because this method, play an instrument, was nothing we could implement at that level, that we wanted to make it abstract, and therefore, as a result, we had to make the instrument class abstract as well. So that meant that we could not instantiate just a generic instrument, and in a sense, that's actually a good thing. In other words, by making the instrument abstract, we prevent just having an instance of an instrument that isn't specific to what it is. Okay, so the idea here now is that there are now special methods in each of these individual classes that do not exist in instrument. So if all I know is I have an instrument, I can invoke a method which exists in instrument, like play, see, because it's there, but I cannot invoke these specific ones. Okay, so that now here's the thing. So supposing I have this example is kind of back when supposing instrument were not abstract and we could actually well, I'm sorry, no, never mind. No, here. Okay, supposing we do this. This is legitimate. Again, I want to keep reminding you of the difference between the type of variable and the specific instance of it. So the variable violin here with the lowercase v, now semantically, this is the name of a variable. There is nothing about this variable in itself that makes it a violin. We've just called it one. And in fact, we define it simply to be of a type of instrument. And that's legitimate because the violin class is an instrument. Okay, this is important to understand. Again, we can define the type to be one thing and the instance to be anything which is compatible with that. So in this case, we could make that instrument a new trumpet. So if I were to say new trumpet instead, as far as Java is concerned, that would be perfectly fine. That's perfectly fine. So I have a variable called violin, which is an instance of trumpet. And that is legitimate because trumpet is an instrument. Okay. Now, chances are you don't want to do that, but that's just sort of a don't do that type of thing. In other words, you want to name your variables something which is as reasonably descriptive of what it is as possible, while keeping in mind that the name in and of itself, in other words, the name of this variable, there is nothing about the name of this variable that makes it a violin. It's this that makes it a violin when I instantiate it. Okay, now here's the thing, is that, so let's say that this is, I have this variable violin and I want to pluck it, all right? If I have a violin, it is legal for me to pluck it because that's a method here. However, if all I have is an instrument, then I'm not allowed to pluck it. Why? Because an instrument does not have the pluck method. Okay, so I'm in a situation, and I know for a fact that this this variable happens to be a violin, even though I've declared it to be an instrument, and that's all I know about it. I am 100% convinced that this is a violin, and now I want to do a violin thing to it. Okay, so how can I do that? Okay, basically this is what the downcasting is about. So I can downcast my instrument to a violin, and this is how I do it. I put it in parentheses before the variable. So here, what I'm doing is I'm defining a new variable, which actually points to exactly the same object. This strad, which is a violin, points to exactly the same object as this instrument violin. Now, if you're familiar with other languages that kind of do this. C++ is one kind of example. You've probably at least heard of C++. Um, they're very loosey-goosey about casting as far as the compiler is not nearly as OCD as the Java one. Okay, what do I mean by that? In other languages, you can cast anything to anything willy-nilly, and they won't pick it up until runtime. Java's not like that. In Java, the compiler will say, all right, they'll look at this, they'll say, you've defined this violin variable to be a type of instrument. And now you're casting it to a violin class. Does that stand a chance? And the answer in this case is yes. It stands a chance because a violin is an instrument. And so this might work. It might not work, but we're not going to find out till runtime. But the compiler now says, okay, you're the boss here. You are convinced that this variable is in fact a violin, and so I will let you cast it to it because it could work. It could work. See, now notice I could, if I declared my violin to be a trumpet, the compiler will still allow this, but then when runtime comes, it'll bomb out because it'll say, whoa, you know, you did a bad thing. Okay, so before we move on, again, here's something that's important to understand. This reference, the violin reference here, and this reference called Strad here, these point to exactly the same object. You have not done anything to this object. So basically the object is sort of, you know, we'll maybe go into this at some point, is somewhere in memory is all the stuff to store the methods, references to where the method code is, references to store where the instance variable is. But in this case, see, this violin points to this place, but this Strad also points to exactly the same place as well. So these are literally the same object. The only difference is the context. Here, the violin variable has the context of an instrument. And so in that context, the only things I can do to the violin variable are instrument things. The Strad, however, has a context of a violin. And as a violin, this is now legal. So the compiler will let this through. However, again, here's the risk. The risk is that because the compiler says, well, I'm going to trust that when the time comes to execute this statement right here, or even this cast right here, yeah, right here at this cast, if this violin variable points to something other than a violin, you will get something called a class cast exception. Why? Because I cannot cast a trumpet to a violin. And if you look at the diagram, that makes sense because a violin is not, a trumpet is not a violin. So if this were to be the case, then and then in the code examples, maybe I'll show that to you. But this could happen. So if the virtual machine allows this cast to take place, then you can now execute a violin thing. So now it's a violin.
Arnie, I have a question.
Yes.
I'm not really understanding the point of it. I push the I believe and like I believe you, but like why would you not just do violin equals new violin and make it easier? I mean, doesn't it still take the properties of the instrument because it's a subclass? It just won't, I guess it won't have access to the private variables, the instantiated ones.
Oh, okay. I think you're mixing a couple things in here. Well, first is the why. Part of the why is that if I have an array of instruments, I can put all kinds of different instruments in them. So, and as we'll start seeing next week, we will have objects, containers that are more flexible than arrays. And so into these containers, we can only put homogeneous things. So if I have a container like an array of instruments, I can only put things in there which are declared to be instruments. Now, if I want to do something with those, then I need to know, I need and especially if I want to do something special, then I need to worry about this. So
But can't you, since violin is a subclass of instrument, can't if the variable is just a violin object, can't you just do that anyway? Can't you put that in an instrument array?
yes, you can, but if it's a type of instrument, I can only do instrument things to it. The compiler will not let me do specific things to the violin that are not an instrument.
So if I instantiated an actual violin, can I now put that in an array, in an instrument array with a trumpet and a cello and a French?
Absolutely, yes.
Okay, I guess I'm just not fully understood. It seems like it seems like it's just doing it a much different way. It's a little convoluted. So I guess I'm just missing something. I'm not sure.
Um, well, just uh, as far as the why goes, that basically the answer is that this has turned out to be useful in many respects. Maybe at this point there hasn't been enough experience with this kind of dealing with this kind of thing to kind of fully get the why. So uh, my suggestion is to just sort of don't press I believe button forever, but for right now, uh, at least accept the fact that sort of generations of programmers have found this kind of thing to be useful.
Yeah, and I'm sure that's it. I assume it's just my, if you're teaching us, it's probably just my ignorance. It's just it for me to actually remember and understand this. Like if I don't understand why, it's probably just gonna get deleted in the next week. So that's I'm just trying to understand it, but I'll go back and review it. And
Well, yeah, first get the what though, and then the why should come. um, a big part of it is the reason for the strong typing is that especially in large programs, keeping strong typing has proved to make programs more bulletproof. Again, if you've ever encountered in JavaScript or in Python a situation where a program runs for a long time and then hits a syntax error, um, that's a reason why strong typing would never, in a strong type language like this, that would never happen.
yeah, I'm not arguing against
Yeah.
that. I'm just trying to gain a basis and trying to figure out like is this useful for us? Like we're just kind of trying to grasp Java right now, and with it being such a strong typed language, it's if you don't have the syntax perfect, like you can't, you're stuck for hours. Um, are we going to be using this right now, or is this something like just log it like this is a thing, and later on we might touch it again?
Well, those of you who are taking moves 3302 next quarter will be using it out the wazoo. Um, so uh, if if you are literally struggling for hours to get a program to compile, then may I gently suggest a different way of doing things. In other words, if you write a line of code and NetBeans complains and gives you the red squiggly, then don't keep writing code. Keep, make sure you get that red squiggly gone before you write another line of code, if that's the case. Otherwise, you will be spending hours trying to make it compile. The second thing is that the more of the strong typing stuff, and especially this relationship of objects, the more of the what you get that, the less time you'll have to spend getting your program to compile. So, and again, this is part of the gear grinding when you go from a non-typed language like JavaScript to a strongly typed language like Java, because what happens is, and this happens to me because these days I do a lot of programming in Python as well as Java. So, and in Python, the typing is much looser. In fact, they're in the new versions, they're starting to realize that the loose typing is not such a great idea. So I'm seeing more, the new Python things have like type hints and stuff like that, which is a step toward that. But when I have done a lot of Python programming and I come back to Java, then I find that I'm not as prone to be strict about declaring my variables, for example. So it just sort of a habit, a context that I get out of if I'm doing a lot of programming in a non-typed language. So it's important to realize that. But again, I can't emphasize this any stronger. If you have a compile problem in typing one line, then do not go any further until you make that go away. Okay, back to the what. Need to watch the time a little bit. Okay. All right, so the compiler will not allow a cast that has no chance of succeeding. So here I can define my variable x is a violin, its type is a violin, and its instance is a violin, no problem. So what I can do is, this is another way of casting. So I can try to cast my violin variable to a trumpet. And that should look kind of the same as what I was doing up here, because I took an instrument and I tried to cast it to a violin. Here now I'm taking a violin and trying to cast it to a trumpet. However, that has no chance of succeeding because a violin is not a trumpet. So this will be a compile error. And again, if you encounter something like that, then don't go any further until you make that go away. So in the difference between we've talked about upcasting before. So upcasting is when I have an instance of a subclass and I treat it like a superclass. And we've seen that with the tune method. So any one of these subclasses can implement the tune method. That's upcasting. I'm casting from below to up. That's the up part. Downcasting is when I take something which is declared to be the superclass and I cast it down. That's what I'm doing right here. Okay, just this to review what we did yesterday. Again, we talked about an abstract class, and again, the reason for this has to do with the fact that these classes are also types. So what's a type is what I can declare a variable to be. And that type is also, can be thought of as an interface in the sense that anything of this type I can implement, I can call these methods on. So sometimes I want to be able to call the method, but I don't want to actually implement it because it's, there's not enough information to implement it there. So I may declare a method to be abstract. And if I do that, then the class itself must be declared abstract. We saw this yesterday with the instrument class. So uh, now, just to add on to that, I can actually declare a class to be abstract even if it doesn't have any abstract methods. All that does is that forces the user to subclass it before it instantiates it. So in other words, an abstract class, I can use that as a type, as I have with instrument, but I cannot instantiate that type. In other words, I can't say new instrument now that it's abstract. I can subclass it, like I can say a trumpet extends instrument, and now I can say new trumpet if it implements the abstract method. So the difference that we have abstract classes, which have the keyword abstract. If it doesn't, then it's a concrete subclass or a concrete class. In order to be a concrete class, if it's a subclass of an abstract class, it must implement all the abstract methods. And as we saw yesterday, I can declare a subclass, but not implement all the abstract methods, but then I have to declare that to be abstract as well. So an abstract class, though, it's like a class in every other way. It has instance variables and concrete methods, or it could have concrete methods. It could have nothing but abstract methods, but it could have a mix. Okay, so we've seen that. Now there's one additional concept in Java called an interface. So we've seen, okay, what are the types in Java? We've seen primitives. Those are so far, the main ones we use are ints, doubles, Booleans. Classes are the other type, both concrete and abstract. We've seen enums, which are a special kind of class. And now this is the final type of thing that you can see in Java, and that's an interface. So what happened was, with experience with these abstract classes, which exist in other object-oriented languages. Java was not the first object-oriented language. In fact, it was in many ways a latecomer to the whole object-oriented thing. But one of the reasons why it's the predominant object-oriented language is that it was able to utilize all the stuff all the experience that the previous ones had had. So an interface is even more abstract than an abstract class, in the sense that a Java interface only contains abstract methods. And this introduces just a very useful concept. Actually, to my knowledge, Java borrowed this from a language called Objective-C, which is actually the language that at least the early Apple 10, the early operating systems were built on. Objective-C goes back to the next system, but anyway, Java borrowed it, the concept, and it turned out to be very useful, because what the interface is a contract for all classes that implement it. The idea is that an implementing class promises to implement all of the methods in the interface. So if I have a class which implements the interface, then if it implements all the methods, then I can make it concrete. If it implements some but not all of them, then it must be declared abstract. Now here's sort of the why of this, though. Now, if you remember, Java is single inheritance, meaning that each class has only one immediate superclass. But a class can implement more than one interface. In other words, and furthermore, an interface can extend another interface. But this is kind of the key thing, is that I can actually implement more than one interface. And we'll see an example of this, or a silly example. Okay, so here's an example of something in Java, and this is something that we're going to come back to, which is a key element of how Java's graphical user interfaces work. These three things, these are all part of Java. Okay, so Action Listener is an interface. Now, for doing graphical user interfaces, one of the things in every interface, or at least many interfaces, is a button. Whenever you want to make something happen, you click on a button. In Java, using one of their main framework these days is called Swing. And the concrete class of the Swing framework uses is called a JButton. But it extends a class called an abstract button. And the reason for that is that anything that you kind of click on and that responds is actually a subclass of this abstract button. And so in Java, what they've done is this abstract button implements a whole bunch of things. It's a huge class, but it implements everything that is common to graphical user interface widgets that respond to a click. Almost all of them extend abstract button, one of them of which is a J button, which is just a normal button. And we're going to see plenty of examples of this when we start talking about user interfaces. So in terms of what we've just been talking about, here's an abstract class, because an abstract button, and in fact, they put the word abstract in to emphasize the fact that it's an abstract class. But the J button, if I want to instantiate an actual button that the user is going to click on, I will instantiate a J button, and then I'll put it on my canvas. And one of the methods that the J button has is something called, well, the button itself will respond to a click, but there's also a method called doClick, which corresponds to what the user does when they click on it. Now, what happens when you click on a button? Well, that's all up to the user. Java has no way, absolutely no way of knowing what the programmer wants to happen when the user clicks on the button. That's going to be up to the programmer. And that's where this piece of it comes in. And the idea is that things that happen to the button, things that happen when a user clicks on a button, are implemented. One of the many ways is something called an action listener. And the action listener is actually defined as an interface. And this is in Java itself. This is an interface. And the interface has a single method. And that single method is called action performed. So any class which implements the action listener must implement the action performed method if it's going to be concrete. So this is something that the programmer, the programmer now, like all these things that I've circled here, these are all part of Java. Now, if I want to make this happen, then what I do is I implement, and this is the symbol for implement. So I will implement this my action listener. I will implement the action performed event, and inside that event, I will write the code that I want the user to happen when the user clicks on that button, and that's how you make them live. And then, in addition to make that happen, there's this concept of listening to. So I will instantiate one of these guys. I'll define this class, and we'll again, when we get to user interfaces, we'll talk about that. I'll define this class. I'll have it implement the action listener interface, and then I will have an instance of that listen to an instance of the J button. And what happens when you listen is that when the user clicks on the button, that will trigger whatever code is in the action performed event method. When the user clicks on the button, then all of the action listeners that are listening in will have their action performed method invoked. So that's how you connect the user interface with, in this case, with what the code is. Okay, and then the final thing is like, okay, now why interfaces? Because this is what gets away from, gets around the fact that Java's inheritance is only for a single class. So here's a multiple interface example. So here's an interface called dessert topping, and here's an interface called floor wax, and here's a concrete class which implements both of these interfaces. And so this instances of this can do both of these. And okay, so that's how you would implement something that has two different stuff. Okay, that was, I don't know if you like, okay, that was short. So now you've been asking for examples, and let's look at an example here. Where are we here? Okay, so what I wanted to okay, I wanted to illustrate okay, the interfaces we're going to deal with in a bit, but let's look at this here. So here's my violin. Let me add the pluck method. Okay, remember now here's a method which is in violin, but is not an instrument. Okay, so let's look back here. Here we had the first element of this array was in fact a violin. Okay, so now as a violin, I should be able to pluck it, but it says it. Now see the message. It says cannot find symbol. The symbol is the method pluck. The location class instrument. See, because combo is declared to be an instrument, I cannot pluck it. However, I'll show you. There are a couple ways of casting. And this is one. I can kind of do it all like this. And now it's now let me see now my violin is plucking that. However, here's where we really, let's play something like that. All right, now. So here I'm saying combo 0 is now being cast to a violin, and I'm saying pluck. So the compiler says, all right, here, what you've done here is you have cast this instrument variable to a violin. That's legal in the sense that this could work. And so given that you're telling me this is going to be a violin. A violin can pluck, and so it will pluck. However, what's going to happen is I'm going to get a class cast exception because this is not a violin, this is a trumpet. And in fact, the messages aren't always that great, but here it is. It says class trumpet cannot be cast to a violin. Blah, blah. So, see, so this is not legal. Okay, so now let's, in the waning minutes, let's see an example of the interface. So I'll do the, okay, again, I create an interface and notice it says public interface dessert topping. And so in an interface, I can only declare abstract methods. I cannot okay, here I'm trying to declare a concrete method, and it says interface abstract methods cannot have a body, meaning that I have to make only, define only abstract classes, abstract methods. Let's see, what did I think, where are we done? Oh, where'd you go?
Have you ever seen a rug that is water resistant, stain resistant?
I think it was wax. Yeah. Okay. So, all right. So now I have two interfaces. Dessert topping has a method called eat. Floor wax has a method called wax. Okay. So again, why do this? Because sometimes I want to have objects where if I treat them in different contexts, then I want to do different things to them. So in this, if I put something on my butterscotch pudding, I want to eat it. If I put it on the floor, I want to wax it. Okay, so how do you do something like this? So now we'll define a class, which, how do I specify? I say implements dessert topping, comma, floor wax. Okay. So notice I can, now I don't have to, I'm not extending anything. I'm simply I'm extending object, but I don't have to say that. If I say implements, I can give a comma separated list of all the interfaces that I'm implementing. Okay, now, but now look, the compiler's complaining. It says Newshimmer is not abstract and does not override abstract method eat. And now once it did that, once it found that, it gave up. Now, one of the nice things that NetBeans offers is that if I sort of click on this, it has the thing, it says implement all abstract methods. That's really handy because it basically stops any fat fingering. And so what it does is it will actually write now all the methods, all the abstract methods are now written, and then all it does is it throws an unsupported operation exception, and that's actually a useful thing because that forces the programmer, me, to actually put something in there. So now even if I don't do anything, let's write our little test method. See, so now if I All right. So now I can say X eat and X wax. Okay, so and the compiler will let me do that because why? Because I've implemented both of these interfaces but now I'm going to get an error. So it's unsupported operation. So let's okay, so now I've done something concrete with it. And now when I run it, it can do that. Okay, furthermore, I can do this. I can declare my variable to be any one of these interfaces. So interface is also a type. The difference is that if I declare it to be as a dessert topping, I can only eat, but I can't wax. So even though this instance is one of these, is an object for which this will work, here it says I can't find the symbol. But what I can do is I can now cast it to a floor wax. And if I do that, that will work in this particular case. What I can't do, though, is I cannot instantiate it. See, it says it's abstract, but an interface is like a pure abstract class. So this can't do this. Okay. Okay, so there's how we can implement. Where'd you go? Here, okay. So this is what was just implemented. So I defined two interfaces. Those interfaces had abstract methods in them. I defined a concrete class which implemented all of the abstract methods. And now I can treat this as, now I can use all of the methods in both of the interfaces.